Today we are on pages 9 and 10, and we are going to focus on surface area of triangular prisms. So a triangular prism follows the same process as a rectangular prism. So again, we are just finding how much space is on the outside, if we wanted to wrap it, if we wanted to have cardboard around it. However, triangular prisms have triangular bases. Basically, they have triangles for the bases, okay? So just a quick review, we could find the area of rectangles very easily by just multiplying the two dimensions together, a 12 by 7, which would be 84 square feet, okay? And then to find the area of a triangle, we still just envision it like a rectangle, so we're gonna do 12 by 7, okay? So we would have a rectangle that's 84 square feet, but this triangle is a triangle, it's not a rectangle, so what we would have to do is we would have to cut it in half, okay? And 84 divided by 2, which would be 42 square feet, okay? Describe what is different about the two shapes in their area. Again, a triangle is half a rectangle. So we have to keep that in mind when we're finding area. If we're dealing with triangles, we have to cut it in half. Okay. The next part is to shade the bases of each figure, because when we think of base, sometimes we think of the word bottom, but base is actually just the side that is like parallel to each other. So for this one, even though the bottom is a rectangle, this is actually a triangular prism, because looking right here, there's a triangle on the left and there's a triangle on the right. So they are actually parallel to each other, okay? Again, while the bottom is a rectangle in this shape, this is still a triangular prism because it has a triangle in the front and a triangle on the back. So again, they're parallel to each other. Okay. And then finally, this would also be a triangular prism because we have triangles on the ends and they would fold up and make a prism. Okay. Next, what we're going to do is we are going to decompose this net into different congruent shapes, and then we will actually find the area of each figure. So let's go ahead and do the rectangles first, because rectangles I think are a little bit easier. Okay, so we have this rectangle right here, and it is a 6 by 8.5. So we're going to multiply 6 times 8.5, and we get 51 square inches. And then we have to look and say, do we have any other ones that are the exact same shape? Yeah, we have this one, and this one. These are all the same shape and size. So what we're going to do is we are going to triple that to get the total for those 3 rectangles. So that would be 153 square inches total. All right. Next, we have our beautiful triangles. Okay, so we know that it is 4 inches tall. What we need to figure out is how long is it. So we have to use our kind of like our deduction skill. So because this is 6 inches right here, that means this would also be 6 inches right here. Okay, so we are going to make a rectangle. We're going to do 4 by 6, which is 24. But then we have a triangle, so we are going to cut it in half and get 12. So we did 6 times 4, but again, it's a triangle, so we have to cut it in half. So 6 times 4 is 24. 24 divided by 2 is 12 square inches. Okay. Now keep in mind, we have 1 triangle, 2 triangles, so we are actually going to double it, and we get 24 square inches for both of the triangles. Then to find the total, we would add the areas together. So we have all of our rectangles, we have all of our triangles, and when we add 153 plus 24, we get 177 total square inches. All right, next we just have 3 problems, finding lateral surface area, total surface area, and total surface area. Remember that lateral surface area is no bases, okay? So bases for this one would be our triangles. So we're not gonna have the 2 bases on the front or the triangle on the back. So basically, we just have to figure out these sides right here. Okay, so first I'm going to do this front side that we can see. Okay, so I see that it is 7 feet long and 4 feet kind of tall. Okay, so 4 by 7 would be 28 square feet. Okay, then if we have this front side, that means we would also have the back side of it. So I'm going to say front and back. Okay, so I'm going to double that, and 28 times 2, which would be 56 square feet. Okay. So we've done the front and the back, and I think the only thing we have left is the bottom. Okay. So the bottom is going to be, I'm going to change colors. It's going to be 4 feet by 7 feet. And this one's kind of hard to see, again, because we can't really like see through it, but we see it's 4 feet on the bottom. And then using our deduction skills, this would also be 7 foot. Right, and 4 feet by 7 feet is 28 square feet. And we only have one bottom. We don't have a top because it's a triangle. So to find the total, we are going to add 56, the 2, the front and the back, and the bottom, another 28. Stop. And we get 84 square feet total. All right. This one says to find the total surface area. So the chocolate candy bar is being wrapped in a cardboard box. How many square centimeters are needed for the box? Okay, so let's go ahead and start off with the front and the back. So let's find this triangle thing. So we'll call it front and back. And it looks like a triangle. Okay, so it says it is 3 centimeters long and 2.2 centimeters tall. Okay, so what I'm going to do is I'm going to do the rectangle. So I'm going to do 3 times 2.2, and then it is, stop it! And then it is a triangle, so I'm going to cut that in half. So 3 times 2.2 is 6.6. 6.6 divided by 2 is 3.3 square centimeters. Okay, but we also have the front, we also have the back. So we are going to go back and double that, and we do get 6.6 total square centimeters. All right, now we have like the left and the right side. Okay. Okay, so we look and we see that this side that we can see, it is 16 centimeters long, and then it looks like it is 2.6 centimeters tall. So I'm going to do 16 times 2.6, and I get 41.6 square centimeters. Again, I have this side that I can see. I also have the other side, the right-hand side that I can't see. So I am going to double that, and I get 83.2 square centimeters. Okay. And then we have the bottom. Okay, so again, this is kind of hard to visualize. Okay, but if we are looking at the bottom, okay, I see this on the bottom. So this is not the same size as the bottom. The bottom is 3. So I'll kind of draw it to kind of help us see it. So 3, and it is 16 centimeters long. So we're gonna do 16 times 3, and we get 48 square centimeters just for the bottom. And again, there's not a top to it, so we only have it one time. Then to find the total, we would add the front and the back, the little triangles. We would do the big sides, the left and the right side, and we would add the bottom to it. So 48 plus 83.2 plus 6.6, and we get 137.8 square centimeters needed to cover this chocolate bar. Okay, last problem. A carpenter is building a unique jewelry box in the shape of a right triangular prism. Okay, the base has, so the base, oopsie, The base, which is a triangle because it's a triangular prism, has measurements of 4 inches, 3 inches, and 5 inches. Okay, and now we have to figure out, oh, I guess it's a right triangular prism. I guess I should draw the right shape, huh? Okay, so a right triangular prism, so a right triangle. It is 4 inches, 3 inches, and 5 inches. Okay, how much wood will it need to complete the base if the project is 6 inches tall? Okay, so first let's just kind of envision what this is. So it's trying to say if this was 6 inches tall, how much wood would it take? Okay, so let's first just find the area of the base. So we have a 3 by 4. Okay, that's a triangle, so I'm going to cut it in half. So 3 times 4 is 12. 12 cut in half is 6. So I also have, so here's the front, but I would also have the back of the jewelry box. So I would double that and I would get 12 square inches. Okay. Now we have to envision like all these different sides. Okay. So we have this side that we can see. Okay. And it looks like it is, and I'll just call it the right side. Okay. So we see a long 6 and a 5. So that would be 30 square inches. Okay. But if we look right here, this side right here is not 5 inches. So we can't double it like we could before. So now let's do the left-hand side. And on the left-hand side, it would be 3 inches by 6 inches. Which would be 18 square inches. Again, this is a different dimension as the bottom, so we can't even use that. We can't even double that for the bottom. So then finally we have the bottom, okay? And we have a 4 by 6 for the bottom, which would be 24 square inches. So we have all of our sides. We have the front and the back, so that's 2 of them. We have this side that we can see, we have that back side, and we have that bottom side. So there's 5 sides, and we can add all of those together to find our total. So 12 plus 30 plus 18 plus 24, and we get 84 square inches, total needed to make this jewelry box. So today your assignment is 4 problems on page 11, just to try them out and see how we do.